Hi everyone. Today we're going to discuss characteristics of quadratics. A quadratic function is a function that can be described by this equation. The ax squared plus bx plus c should look familiar from last unit when we were talking about factoring. A parabola is a U-shaped graph. It is the graph of a quadratic function. We have three forms of quadratic equations. We're going to talk, here we have listed two of them, and then we're going to add in the third one over here. So standard form is just that. It's the same one that we've been looking at over and over again, last unit and what I have up here. The only difference is I've replaced the f of x with a y. And if you remember from past units, f of x and y mean the exact same thing. Our factored form looks like this, where a is that greatest common factor, and then the s and the t, those represent other numbers. Okay, so once you take something that's in this form and you factor, remember we have numbers here and here. Our vertex form. Now this is one we don't use very often in Algebra 1, but you will definitely see it in Algebra 2, so we like to just introduce it to you. So here's our vertex form. Vertex form, that A tells us if it's going to open up or down, or if it's a stretch or compression. The H tells us if it's, tells us the X value of the vertex, and the K tells us the Y value of the vertex. All right, let's come down here and talk about the axis of symmetry. The axis of symmetry is a vertical line that runs through the vertex and splits the curve evenly. We can use this formula to find the axis of symmetry. The vertex is the highest or lowest point, also known as the maximum or minimum of a parabola. Alright, so let's go through and let's talk about some of these characteristics. The parent function is just y equals x squared. So let's take a look at what happens with some of these pieces. All right, so if my a value, that's the coefficient of x squared, is greater than 0, that means if it's positive, the parabola opens up. And it has what we call a minimum. So if I were to put this into the graphing calculator, okay, we would end up with a graph that looks like this one here. So right here is my vertex at the origin 0, 0. And then I've got a point at negative 1, 1 and a point at positive 1, 1. And then I've got a point at negative 2, 4 and positive 2, 4. So this right here is my parent function. Now, if my a value, my coefficient of x squared, is negative, right, less than 0 means it's negative, then that means that it's going to open down, and we have what we call a maximum. So the minimum means it was our lowest point. The maximum is going to be our highest point. So it would look more like this blue one here that I just graphed in. So it would look like that. If your a value is between 0 and 1, so it's positive, but it's like a fraction, 1/2, right? Then my parabola gets wider. It's going to look more like this one here. And if my a value is greater than 1, then my parabola is going to actually get narrower and look more like this purple one here. Okay. All right, zeros. Oh, I did not hide those, so just hold on to these for just a second. Our zeros are also called our x-intercepts, our roots, and our solutions. Parabolas can have 0, 1, or 2 zeros for its functions. If it has 0 solutions or 0 zeros, it's going to look something like this, where it never touches the x-axis. Right? Keyword x-intercepts. If it has 1 0, it means that just the vertex touches the x-axis. And if it has 2 zeros, then it means that my parabola completely crosses the x-axis and we hit the x-axis twice. All right, let's go to the next page. And let's talk about graphing a quadratic. All right, so what do I need to graph an equation? Well, my axis of symmetry is helpful because I can use that to then help me find my vertex. And then we can make a table for all the other points. So if we remember correctly, our axis of symmetry formula is this. So remember, it goes ax squared plus bx plus c. My a value is the coefficient of x squared, my b is the coefficient of x, and my c is my constant. The signs in front of those values go with those numbers. All right, so when I go to substitute in my values, I got my negative, my b was 4, and my a was 1. I can really just take that negative and I can bump it up with the 4 just to make my math a little easier to deal with. And I end up with negative 2. So my axis of symmetry is x equals negative 2. I can graph that in if I wanted to, and it would look like this. Just a vertical line. Here's my x equals negative 2. Now to find my vertex, I have the x value. Now I need to figure out what's the y value. So I can take that negative 2 and substitute it in. So there's the equation. Now I'm going to substitute in that negative 2 for my x. Make sure that you always put your number inside parentheses. Do the math, and we end up with y equals negative 9. So my vertex is negative 2, comma negative 9. So that puts that point right there. All right, now we can make a table for the other points. So to do that, we can pull out our graphing calculator. Okay, so if I open up my calculator, oh, hold on, let me pull this up. All right, so for some reason, I cannot get this. All right, hold on one second. Okay, now I can get to my calculator. So if I were to go into my calculator, I can go to y equals, and I can type in this equation. So I can do x squared plus 4x minus 5. And now I can hit graph. So now I can see what it's supposed to look like, but what we want to do is make a table for those other points. So here's going to be my table. And now we can go ahead and we can use the table in the calculator to find those other points. All right, so to do that, I'm going to do second table. And what I'm going to do is I'm going to locate that vertex, that negative 2, negative 9. So these are all positives, so to get to my negatives, I'm going to scroll up. There's my negative 2, negative 9. And what I'm going to do is just list some other points that I could possibly also graph. So I'm going to scroll up until I know I can't graph any more points. All right, so it looks like my window is going to be the negative 6, comma 7, all the way through my 2, comma 7. I'm just going to copy that table essentially into my table on the paper. So there's all those x values, and then there are all those y values. So now this table matches what we had in the calculator. The negative 6, 7, the negative 5, 0, negative 4, negative 5, negative 3, negative 9, 8, negative 2, negative 9, negative 1, negative 8, 0, negative 5, 1, 0, and 2, comma 7. All right, so now we can go ahead and we can graph all of those points. So I can go to negative 6, let's see, 6, and then up to 7. So I'm going to scroll up a little bit more. I got a point there. I've got negative 5, 0. I've got negative 4, negative 5. And then I've got negative 3, negative 8. And then I'm going to, we already have our vertex, and then I can come up and I can hit the other side of my parabola. And then once I've done that, I can actually graph my parabola, which would look something along these lines. Now hopefully yours is going to look a little better than mine. It's kind of hard to draw in on the computer. Now this one is a try on your own. And again, we are doing these in class, but if you're not in class, then you can go ahead and try that on your own. Alright, so now let's see how we write, oh, actually I forgot though, for that try on your own, that equation ended up being the exact same as the one that was already there. So we're going to cross this one off, and for the try on your own, you're actually going to use this equation here. X squared plus 2x minus 3. Okay, so now let's come over here and writing an equation from a graph. So our step 1, we're going to find the zeros of the graph, and then we're going to set them equal to 0. Step 2, we're going to unsolve the equation by moving the number over to the same side of the equal sign as the x, and then set that equal to 0. And a reminder, just use your inverse operations. Right? And then we're going to multiply the factors to get our equation in standard form. Alright, so our zeros are where we cross the x-axis. So in this case, my zeros are 1 and 3. Alright, so to get my factors, so my step 2 is to unsolve this equation. I want to take this 1 and I want to bring it over to the x. Remember, anytime I move something from one side of the equal sign to the other, I use that inverse operation. If this is positive, then I'm going to subtract 1 from both sides. And when I do that, I get x minus 1 equals 0. And now I'm going to do the same thing here. I'm going to subtract 3 from both sides, and I end up with x minus 3 equals 0. My factors are that x minus 1 and that x minus 3. And then we also have this negative 1 here because it opened down. And that told me that my coefficient of my a value, my coefficient of x squared, was negative. So we always pull out that GCF, that greatest common factor, and in this case we would just pull out a negative 1. So negative 1 is one of our factors. That's how we make it turn upside down. Alright, so my factored form would look like this. Y equals negative 1 times x minus 1 times x minus 3. Right, well now my standard form is now I'm just going to multiply all these together. So if we remember from last unit, I can make my box, and I can do my x minus 1 on the top and my x minus 3 on the side, and now I can multiply everything together. X times x is x squared, negative 1 times x is negative x, negative 3 times x is negative 3x, and negative 1 times negative 3 is 3. We combine our like terms together, and we end up at this stage here. Remember, I haven't done anything with that negative 1 yet, so that just comes down. Now I can take that negative 1 and distribute it to everything inside. Or actually, before I do that, I am going to combine those middle like terms, so I end up with this. Now I can distribute my negative 1, and we end up with this. And then it really should say y equals. So let's just add that in. So it really should say y equals. So now we have our standard form. This try on your own, cross it off because we cannot identify our zeros right now as it is. So we're just going to cross this one off. And that is it for these notes. Well, everything will be done in class from this point forward, but this is something that you can utilize if you are absent from class or if you would like to preview the notes before coming to class.